In this video, we will learn event-based analysis. As you can see that this is a network diagram, and here activities are represented by arrows. So this is an activity on arrow network diagram. We are interested in knowing what should be the time in which the project can be completed. Activities are shown on arrows, and below arrow you can see some numbers written. They are the activity time. So for event based analysis, first thing is all the nodes, these 1, 2, 5, all these nodes 1, 2, 3, 4, 5, 6, 7, 8, 9, they are events because they indicate completion of some activity, and some activity may be ready for a start. For example, if we take event or node number 5, this is an event which indicates that activity E and F are over and G is ready for a start. Similarly, say node 2, this is an event which indicates that activity C is over and J is ready for a start. Say node 7 indicates that activity A and J are over and K is ready for a start. Remember that if more than one arrows are ending at any node, then both these activities should be getting over. If I is over but J is not over, you can't say that we have reached on node 7. Similarly, if J is over but I is not over, again you will be saying that we have not reached node 7 and K is not ready for a start. Both should be over, and this concept is very important in finding earliest time. So for nodes or events, we have two kinds of time. That is earliest time, that is the time before you can't be on that node. And similarly, we can have latest time, that indicates that by that time we must be on that node, otherwise something wrong will happen. Something wrong is basically the project will be getting delayed. For events, there is nothing like duration. It happens at some time moment. Like when A is over, that is the moment when event 4 happened. Activity A takes 35 days time, that's okay, but when activity A starts, you can say that an event happened, and when activity ends, that time you say at that moment that A ended, and if end of this activity is an event, then you say that that event has happened. So for that event, either you will have earliest time, latest time, is earliest time or latest time, and let us calculate here how we can find these times. So the method is that for the start event, that is the node at which there is no activity ending, this is a start, and for this the earliest time we take as 0. Then for the next, say if we have to find out the earliest time for node 2, then the question is that earliest when we can be on node 2. Now being on node 2 means C should be over. So C starts at time 0, say, and that is the earliest possible, and it takes 15 days time. We in this technique don't reduce the activity time unless the process is improved or some extra resources are put. So we have to give sufficient time, that is 15 days for C. So when you give 15 days, earliest you can be on node 2, that is after 15. Similarly, for node 3, if we have to calculate, we can say that B requires 23 days time, and since that starts at node 1 and the earliest time for that is 0, so 0 plus 23, earliest you can be on node 3 after 23 days. So I put here 23, that is the earliest time. For node 4, similarly, the earliest time will be 0 plus 35. So then for node 5, now this is a node where two activities are ending, E and F both. Now as you know, if E is over and F is still continuing, then we don't say that we have reached on that node. So we need to see from both the sides, that is from E side as well as F side. Now for E, if you calculate, E starts after 35, and then because E starts from node 4 and earliest you can reach on node 4, that is after 35 days. So you require another 10 days for E to be done. So 35 plus 10, that becomes 45. So for E, you see that it requires 45 days from the beginning. Then for F we do, then here you notice that on 23 it starts, it takes 25 days, so 23 plus 25, it will be needing 48. Now out of these two, one will be considered earliest time of node 5, and here there may be some confusion, like when you say earliest time and you pick 45 thinking that this is lesser, note that after 45 days you will notice that 35 plus 10, this is giving you 45. So after 45 days E is over, but F, which starts after 23 and requires 25, that is still continuing, that gets over after 48 days. So if you take 45 as earliest time, then you make an error, because after 45 days E is over but F is not over, and so you can't say that you have reached node 5 and you can't start G. So that's why you should take 48, that is a higher values, because at 48 days F is over and E is also over. So we take 48 as earliest time for node 5. That is, you need to check how many arrows are ending there, and on that node, from all the arrows side, find out the time and then take the higher value. That is what we do for earliest time. Then for node 6, it is easy, only one arrow ending, and D can be started after 35 because it starts from node 4 and another 15 days, so 50. 35 plus 15, that is 50. That is the earliest time for node 6. For node 7, similarly, if we do, here again two arrows are ending. So you have to calculate from both sides. From I side, if you calculate, you find that it is 23 plus 18, that is 41. And from J side, if you compute, it is 15 plus 20, 35. So you have to take the higher value. So we will be taking 41. So for node 7, 41 is the earliest time. For node 8, similarly, it will be 41 plus 10, that is 51. So I write here 51, that is the earliest time for node 8. And then for node 9, you see there are three arrows ending. We'll have to compute from all the sides. From H side, if you take, it is 50 plus 20, 70. From so let me write that here, 70. Then from G side, it is 48 plus 30, so it is 78. And from L side, it is 51 plus 22, that is 73. So highest is this 78, which is coming from 48 plus 30, that is Z. So we take the highest value, and so 78 is the earliest time for node 9, which is the end node. So now this project can be completed in 78 days time, because node 9 is the end node. Here from this node there is no other activity starting. Now the convention is that if the project can be completed in 78 days, then let us complete it in 70 days only. It means that the latest time is taken as the earliest time of the end node. So here we make the latest time of node 9 same as the earliest time. So this is, I write above this, say the latest time is 78 for the end node. Then we calculate back. The latest time is having the meaning that if we don't do that by that time, then the project will not be getting over in time. Project will be getting delayed. Obviously, we are not going to reduce the activity time of any activity. So latest time we have to compute considering that by that time we must be on that node. So let us do it for, say, node 8. This node 8, here L starts, and that takes 22 days time. So at the end L must be finished latest by 78, because it has to be completed before the project ends. Now we must be on node 8 by such date that we get 22 days to finish L before 78. So latest time will be 78 minus 22, that is 56. That is, even if we be on a node 8 by 56 days, you are getting 22 days time for L to get over before 78. So what we did for latest time calculation, we took the latest time of the node which is coming at the end of the arrow, and we subtracted the activity time to get the latest time of node 8, because we wanted this much time, activity time, before the latest time of the subsequent event. This is fine as long as only one arrow is starting from the node. So if we have to calculate the latest time for node 7, say here, then you can take 56, that is the latest time of node 8, minus 10, because you need to do k in 10 days. So 56 minus 10, that is 46. That is the latest time for node 7, because even after 46 days, if you start k, you get 10 days time to finish k before 56. Similarly, for node 6, you can say you require 20 days to finish H, and this should be done before 78, that is the latest time of 9. So 78 minus 20, that gives 58. By 58 we must be on node 6, so that you get 20 days to finish H. Similarly, say for node 5 also, you have only one arrow starting from here, so you need to just check for this. Since G requires 30 days and you must get 30 days time before 78 to finish G, so 78 minus 30, that is 48. So on node 5 you must be latest by 48. Now we have done for node 6, 9, 8, 7 and also 5. Now coming to node say 4. Now on node 4 there are two arrows starting from here. So you have to meet both the conditions. You need 15 days before 58 to finish D, and you also need 10 days before 48 to finish E. So now for node 4, since we require say 15 days before 58, so 58 minus 15, that gives us 43. That is for D, that is to do D in 15 days before 58 you must be here by 43 days. But from E side also if you check, because from node 4 there are two arrows starting, so for E side if you check, E must be finished before 48, that is the latest time of node 5, and then you require 10 days, so 48 minus 10, that is 38. That is the condition being put from E side. Now one of these two will be taken as the latest time. Now again here, suppose you take 43 as latest time, then 43 plus 10, so 43 plus 10, that gives you 53. You will notice that E will be getting over after 53 days, so you will not be able to reach on node 5 before 48. So here you are going beyond latest time, and that will have impact here because after 53 days only G will be starting, so 53 plus 30, it becomes 83, and your project will be getting delayed. It won't be getting over in 78 days time. So obviously 43 is not the right choice. 38 is the correct choice, because in that case 38 plus 10, that is in 48 days E is over, and 38 plus 15, that is 53. So before latest time of node 6 D is also over, so your project is not getting delayed. So you will be taking this value 38 as the latest time. It means for latest time we are calculating from all the sides and taking the lower value. Now if you recall, for earliest time calculation we were checking how many arrows are ending at that node, and from all the sides, that is from say for 5 you will be computing from E and F both the sides, and that is the forward calculation, that is you are adding activity time to earliest time of the previous node, and whatever you are getting from there you will be taking for earliest time calculation you are taking the highest value, and for latest time calculation you are doing the other way, you are doing backward calculation, and you are checking at that node how many arrows are starting. If you have say more than one, say in this case you have 2, so you calculate from both the sides, that is from D side as well as E side, and then you take the lowest value, that is we have taken 38, not 43. So now we have done for 4. Similarly, if we do for node number 3, then here again two arrows are starting from this node, so you need 48 minus 25, so that is 23, and from this side 46 minus 18. So obviously this 48 minus 25, that 23 is the minimum, so the latest time will be 23 for node 3. For node 2, since only one arrow is there, so 46 minus 20, that gives 26, so that is the latest time for node 2. And for node 1, if you calculate from all the three sides, because there are three arrows starting from node 1. So if you compute from A side, it is 38 minus 35, that is 3. From B side, it is 23 minus 23, that is 0, and so that will become the minimum. So now you find that for node 1, earliest and latest time both are same as 0, but for other nodes, like say for node 2 it is 1526, for node 3 it is 2323, that is both are same, but for 4 it is different. For node 5 again you have 4848, for node 6 it is 5058, so again you have some extra time there. For node 7 it is 4146, so again some time. Now as you notice that on few nodes earliest time and latest time are same, but for few nodes they are different. So the nodes where earliest time and latest time are same, you just don't have extra time in hand, so if you connect those nodes and whatever activities are lying on that, those activities are called critical, because you have to start them in time the moment they are ready for a start, and you have to finish them, and you just don't have extra time there. So if we connect all those nodes, then we get the critical path. So here from start, say from 1 if you do, then this is the line, that is 1 3. Here you are finding that earliest time and latest time are same. Similarly, now next is this node 5 where earliest time and latest time are same, so we connect like this, and then obviously on node 9. So we notice that these activities, that is B, then I, no F, B, F and G, that is B, then F and G, these are lying on the critical path and they are the critical activity. Remaining all other activities are having some extra time, and so when we have to give priority to various activities, we need to give higher priority to those activities where we don't have extra time in hand.